Moving objects in one direction have a few variables to cause change. Displacement delta x is the measurement of how much the object's position has changed. Velocity v is the rate of how much displacement changes over time. And acceleration a is the rate of how much velocity changes over time. To find velocity, start with the initial v, multiply acceleration by the time elapsed. Sum these two and you get final v. Vf equals v naught plus a times t. To find displacement, start with both these, average them and then multiply by t. Using these equations you can find more formulas. This is 1D kinematics, based on algebraic mathematics. But to correctly use this content, acceleration must remain constant, whether in the x or y direction. There is only one dimension of motion, vector quantities of magnitude and direction. Scalars only have magnitude. Distance is scalar and the total value. Displacement's final minus initial. Speed is scalar, velocity vector. Speed has no direction. Average speed depends on distance. Average v on displacement. Velocity has direction. Now let's look into projectile motion, known as 2D kinematics. For these objects there is motion in both the x and y directions, so how do we find the variables? Separate the known values into their components using vector trigonometry. And solve each equation like in 1D kinematics. Components are sides in a triangle. Then all you use is the Pythagorean theorem to find the combined dimensional value of a delta x or v. If it's a vector, you will see when missing all but side and angle. Use SOHCAHTOA to find the other sides. Use the values to solve for all other needed missing variables. A constant x velocity means that for acceleration there's nothing, so the initial and final v's will have the same directional speeds. Since gravity is minus 9.8, upwards y velocity will stagnate, but the projectile's motion at the top of the arc. So the values you have are vfy1 and v0y2. They're both equal to 0 using all the given values. So for the variables as needed, use the vector triangle to find the final 2D solution. As long as t, d, a, and velocity are separated into components, horizontal and vertical motion are independent of each other. If a vector has an angle, use sine and cosine to solve for the x and the y components. When finding an angle with two sides, use an inverted trig function to solve for the 2D vector. One-dimensional kinematics only has variables on one axis. There are two types of values, and those are scalar and vector. Both values have magnitude, but only vectors have direction. Two-dimensional kinematics have variables on two axes, so they have to be split between the x and the y components and solved using one of two things, either trigonometry or the Pythagorean theorem. Remember that horizontal and vertical motion are separate. The motion of objects without forces.